Well, hopefully you're feeling it too. Tonight's going to be a great night. We're going to practice a little more with accumulation functions. So we'll just title this Accumulation Functions 2. Now, one way to think about this is to picture like a Pac-Man figure. And remember that our accumulation function is basically, I'm going to have a constant down here, and I'm going to have this little Pac-Man figure who's just going to eat up area until we tell it to stop. Okay, so my accumulation function, again, has this upper bound that's a variable, okay, like a Pac-Man, that's just going along and eating up area. Alright, so let's take a look at our first example. The graph of f consists of 4 line segments as shown below. Let h be the function given by h of x equals the integral 0 to x of f of t dt. Alright, so the first thing I'm going to do, of course, is go get my area. And remember, the area represents the function to the x-axis. Alright, so I have these 3 triangular, maybe 4 triangular sections. I'm going to go ahead and find the area. So, of course, 1/2 base times height. I get a positive 1 for that section, positive 1 for that section. I'm going to split these up this way. It's going to be a -3 and a -3, and hopefully you agree with that. Alright, part A. For each of the following, we want to evaluate h of 2, h prime of 2, h double prime of 2, and find the value and explain why it doesn't exist. Alright, so let's slow down. First of all, who is this a graph about? Okay, let's recall this is a graph of f. All we have to do is read and it tells us there. This is the function I'm going to use when I see h. Alright, so again, this is f, this is h. I want h of 2, h prime of 2, and h double prime of 2. So the first thing I like to do is I'm going to take h, and I'm going to go get h prime. Alright? And I think it's always smart to jot these down when you know you need them, because you probably need them several times throughout the problem. So h prime literally means take the derivative of each side. The derivative of h is h prime. The derivative of an integral is the second fundamental, where it takes the upper bound, substitutes it in. So I'm going to say equals f of x, and then times the derivative of the upper bound, which is 1, so times 1. H double prime, I would then take the derivative of h prime to get h double prime. And if I took the derivative of that side, I need the derivative of this side. So equals f prime of x. Okay, and again, I think you're crazy if you're not going to jot those down off to the side. Now look how simple this is. Part A wants me to find h of 2. Okay, so I'm simply going to plug 2 into that integral from 0 to 2 of f of t dt. Okay, now again, take note. 2 went into the variable x, so it only goes into x in this integral. Now it says integrate from 0 to 2 of function f. That's this graph. And I can clearly see the area from 0 to 2 is -3. Alright, let's go get h prime of 2. Once you made the cheat sheet, look how easy this is. H prime of 2 is equal to f of 2. Okay, so now I'm going to go use my graph, and all I'm doing is evaluating f of 2. So I go to f of 2 has a height of 0. Last part, h double prime of 2. Okay, again, let's use our little cheat sheet. I'm using this one. H double prime of 2 is equal to f prime of 2. Okay, so again, I'm going to go to graph f. I'm going to go to 2, but this time I want f prime. I'm going to look at its slope. Now you'll notice it comes to a corner. Alright, so we're going to say that the slope does not exist. Alright, moving on, part B. For what values of x in the open interval is h decreasing? Explain your reasoning. Alright, so let's think about our justification. The second I see the word decreasing, I know I need to take a derivative, okay? That should be going off in your head right away. The words increasing, decreasing, max, and min all mean take the derivative. Now you don't have to guess who they tell you to do. It tells you. You are taking the derivative of h. Okay, so the first thing I'm writing down is h prime of x, which is equal to f of x. Okay, again, from our cheat sheet. Using it again, h prime of x, which equals f of x. If I'm decreasing, what do you know about those values? You're right, we want them to be less than 0. Alright, so that's the whole setup to the problem. If you can get that, this question's easy. Now just ask yourself, when is your function less than 0? Well, here's your function. Clearly these are positive, these are negative, and these are positive. So I would say from -2 to 2. Now you're going to like this. When it says explain your reasoning, that is this jargon right here. You don't need to say any more than that. H prime of x, which equals f of x, is less than 0. Okay, and yes, we want that whole thing written out. All right, part C. For what values of x on the open interval is the graph of h concave down? All right, again, let's grab those key calculus words, highlight them. Concave down. All right, the second I see that, I am thinking second derivative. Okay, and again, you don't have to guess who to take the second derivative of. Look, it's even in italics. I need h double prime of x. Okay, now use your cheat sheet. H double prime of x, which is equal to f prime of x. If you're concave down, what do you want to be? Less than 0. Okay, so there's your explanation or your justification. Now we just need the section where this is true. I want f prime to be less than 0. This is a graph of f. If I want f prime, now you say look at the slopes. F to f prime is looking at slopes, and I need negative slopes. So let's start at -4. -4 to -2 is a negative slope. Now I have to stop there because the slope does not exist. Then -2 to 0 is negative. I have to stop here again because the slope does not exist. Now I have positive slopes, stopping again, the slope does not exist, and positive slopes. So hopefully you would agree from -4 to -2 and from -2 to 0. Okay, and again, our justification is right there. All right, now the fun part. It says on the axes provided, so you'll have to draw your own here, sketch a graph of h on the closed interval -4 to 4. Now, at first it might look a little intimidating, but believe it or not, you actually know a value already on h. Okay, again, we're sketching h, and if you look back in part A here, we already found h of 2. Right here. When h of 2 equals -3. I'm going to go ahead and plot that point right away. All right, I know one point on my graph. Now, you could easily go get a bunch of points. Think, how did you find that value? All right, you have a function for h. H of x equals the integral from 0 to x of f of t dt. You could just sit there and plug a bunch of numbers in, worst case scenario. So let's do that for a couple. Let's say I want h of 4. Okay, if I want h of 4, I would just integrate this sucker from 0 to 4. Okay, and again, that's just looking at the area from 0 to 4. And if I peek at it from 0 to 4, that's -3 plus 1. Gets me a -2. So I can plot that point. Okay, probably my favorite bound to plug in this particular problem, since my lower bound is 0. If I make my upper bound 0, how much area did you accumulate if you go from 0 to 0? Well, none, of course, so I know that value is 0. I'm going to find another one. Let's say we want h of -2. So I'm going to integrate from 0 to -2. I'm going to say, hold up, those are backwards, so from -2 to 0. And if I look at my picture from -2 to 0, that's -3, but I switch them to make that a +3. And let's see, I'll go ahead and plot one more. I'm going to go -4, 2. All right, now we got to watch whether we're obviously increasing or decreasing, and I think it's obvious in some places. Obviously from here to here to go up, I need to increase, decrease, decrease, increase. I really have to watch my concavity of f. Okay, so here's what I'm saying. Concavity is the second derivative. H double prime is equal to f prime. So if I want to pay attention to my concavity, I have to look at the what of f, the slope. Okay, so from -4 to -2, f has a negative slope. So if f slope is negative, that means h double prime is concave down. Okay, so I know I'm concave down in that section. From, let's see, -2 to 0, if I look at that, again, from -2 to 0, the slope of f is negative, which tells me I'm still concave down. From 0 to 2, the slope is positive, so we're concave up. And again, from 2 to 4, the slope is positive, so we're concave up. Okay, so now let's make it look up, and let's continue to make it look up. So I know h has to look like this. All right, party. Suppose that f is defined for all real numbers x and is periodic with a period of 8. Now, we probably haven't talked about the word periodic since you talked about sine and cosine graph. All periodic means is how long it takes to complete one cycle. Now, since they said you have a period of 8, that means you need 8 units to complete a cycle. Well, if I go +4 and -4, that's a total of 8 units. this is what one cycle looks like. So basically, it's just going to keep repeating itself. It's going to look like the same thing over and over every 8 units. Says the graph above shows one complete cycle. All right, given that h of 4 equals -2. All right, at this point, bells need to be going off in your head, and you need to be saying you have an initial condition problem. Okay, every time they give you that initial condition, you've got an initial condition problem, which talks about that initial versus want setup. All right, so now it says find h of 12. If I want h of 12, okay, remember that's your wants, equals your initial plus your initial to your want. So h of 12 equals h of 4 plus the integral from, okay, 4 to what I want, 12. Now think about this. Who would you integrate? Who would you integrate to get h of 12 and h of 4? Okay, I'm thinking you have to integrate h prime of x dx. Would you agree with that? If you want h of 4, you have to integrate h prime. And at this point, hopefully this is pretty nice. So I get h of 12 equals h of 4, which is -2, plus the integral from 4 to 2 of h prime. Now let's think about this. The integral from 4 to 12, not 2. 4 to 12 is how many units? Okay, that's a total of 8 units. And they told us 8 units is the length of one period or one complete cycle. And if I look at this, every 8 units will be the exact same. Okay, so from here to here is one complete cycle, whether it happens from -4 to 4, or from 4 to 12, or from 12 to 20, every cycle will be the same amount. So if I just take the area in this section, 1 plus 1 is 2 minus 6, I get -4 there. So I can say h of 12 is equal to -6. All right, now I do see that there's another part to this question. I'm going to kill that for now because I want to move on to the next question. All right, the graph of the function f below consists of a quarter circle in 3 line segments. Let g be the function given the integral from x to 4 of f of t dt. All right, so let's slow down and get a couple things clicking here. I want to be clear that this is f, and let's go ahead and get those areas. So I'm going to go 1/2 base times height. Let's see, that's an area of 1. There's a nice 4. 1, 2, 3 by 2, so that's a -3. 2 by 2 is 4, so 2. Now notice that's a quarter of a circle. All right, so that's 1/4 pi times the radius. There's my radius squared is 2. 2 squared is 4 times 1/4. So I'm going to say that's just pi in the end there. Okay, I'll break it up there. All right, now the other thing I know we're going to probably need is g of x, g prime, and g double prime. All right, so let's be smart. Is there something wrong with g of x, first of all? Okay, so let's go ahead and rewrite that. Hopefully you've caught that. And remember our accumulation function, we need to be gobbling up the area in the upper bound. So I'm going to flip that and say that goes from 4 to x of f of t dt. Okay, now I can go easily get g prime, use the second fundamental theorem of calculus, derivative of an integral, take the upper bound and substitute it in, and then the derivative of the upper bound. So hopefully you got -f of x. And once you have that, g double prime is just the derivative of this function here. So g double prime would be equal to -f prime of x. All right, now we can go answer the questions. Letter A, find all values of x in which the integral, find all values of x on the closed interval such that g of x equals 0. Now take note that they said all values, okay? Now again, slow down. G of x is this integral. The question is, when does that integral equal 0? Okay, and I've got several different answers that I can come up with. One is extremely obvious. Okay, what's one x value, without even looking at this at all, what's one x value you could put here to get your function to equal 0? Hopefully you've nailed it. If the bounds are the same, you automatically get a 0. So I know 4 is going to work. Okay, now is there another number you could put there so you get an answer of 0? All right, so here's what I'm thinking. I notice my lower bound's 4, so 1, 2, 3, 4. I'm starting here. Okay, if I integrate from 4 to what, will I get an area of 0? Well, if I go forwards, okay, if I go from 4 over here, I'm not going to get 0. How about if I go backwards? What if I go from 4 to 3? Well, that has an area of 1. But how about from 4 to 2? What happens to those two areas? Do you see how those are the same shape? This section's positive and this section is negative. Those are certainly going to cancel each other out. So I would say from 4 to 2 would get me an area of 0. Could you come up with one more section? Okay, well again, I'm starting here. Could we get one more section where we have an area of 0? Okay, well, we already know if I go from there to there, that's 0. What if I go from there? No. There, no. How about this number here? If I look at all that area, these two will cancel each other out, and those green ones will cancel each other out. So there's another time, if I use -2, I can get an area of 0. All right, so just slow down and take a look at it. Part B, find the x-coordinate of each local maximum of g on the open interval. Justify your answer. All right, we're ready to find that key calculus word. To me, the word that sticks out is the word maximum. Again, every time I see min, max, increasing, and decreasing, I am taking a derivative. Now again, you don't have to guess. It tells you, take the derivative of g. Okay. Now if we were smart, we've already done that. G prime of x is equal to, look at your cheat sheet, G prime of x is equal to negative f of x. Okay, and if you're a max or a min, you are equal to 0. All right, so the first thing that's got to be on every paper is that you set your derivative equal to 0. Let's star that. That's the first thing. Derivative has to equal 0. All right. Now, one little hiccup is we don't actually have a graph of negative f of x. We have a graph of f of x. So how do you negate that? All right, basically, I'm just going to go through and I'm going to take all my y values and make them negative. If I negate the y, I'm really flipping over the x. So I'm going to redraw this function and flip it over the x-axis. Okay, so let's be clear. My blue graph is negative f of x. So when does negative f of x equal 0? Okay, well, my endpoint is -4. It hits 0 at 0. It hits 0 at 3. And then not again, but I do know I have to end at 6. Okay? So again, this is g prime slash negative f. Between -4 and 0, okay, my function is negative. Between 0 and 3, my function is positive. Between 3 and 6, my function is negative. So if you put your arrows in, just like we did back earlier in the year, you can clearly see you have a max, again, follow the humps, you have a max at x equals 3. Okay, justification, of course, g prime slash negative f of x changes from positive to negative. Okay, we've got to have that written down. G prime slash f, that's not an option, changes from positive to negative. All right, part C. Find the average rate of change. Bam, there's a lovely formula. Average rate of change. Now, who are you going to do it to? Of g. All right, and here's my interval, a to b. So I'm going to say that's g of 3 minus g of -2 all over 3 minus -2. Okay, denominator nice and easy. I get a nice 5. G of 3. So you might have to slow down now and go get that value. All right, a little side work here. And I am running out of room. G of 3. I'm just going to plug 3 into my g equation. And that g was the negative integral from 4 to x. So negative integral from 4 to 3. And I'm also going to need the negative integral from 4 to -2. Okay. All right. These are clearly in the wrong order, so I'm going to flip them and pull out the negative. So I'm going to integrate from 3 to 4. And if I look at my area from 3 to 4, looks like an area of 1. Minus, I need the area from 4 to -2, so again I would say those are in the wrong order, so I'm going to flip them and go from -2 to 4. So if I go from -2 to 4, I think that looks like 0. So I would say I get a nice answer of 1/5. Alright, for part D, I'm going to squeeze it in here. I'm going to cross this off because this was from our previous problem. It says, for how many values of C is G prime equal to the average rate found in part C? Okay, so it says, when is G prime of X equal, it says it right there, to the average rate found in part C? When does G prime equal 1/5? Now look back at your cheat sheet. G prime is equivalent to -f of x. So I'm also going to say, when does -f of x equal 1/5? Now I think this is easily solved by looking at a graph of it. So let's look at the graph of -f of x and the graph of 1/5. Okay, so the graph of -f of x is in blue. And in purple here, let's draw our graph of 1/5. So I'm just going to draw 1/5 in. And it just says, how many times does -f of x equal 1/5? I would say it happens twice. And we can see it right there. Well, perhaps this seemed like a little overload to you. It is the second day we're attempting this. So if you need to pause, rewind, go back, do what you need to do. But we need to be pretty proficient at this when we come in tomorrow. Have a great night. We'll see you then.